Today's lesson is Chapter 5, Lesson 3, and it is Angles of Triangles. And first things first, I would like for you to scan the lesson, and I want you to list two headings you would use to make an outline of the lesson. All right, so now let's take a look at this real-world link. Caroline and Emily are building a bridge out of toothpicks for a science competition. Emily thinks the sides should be constructed using triangles. Use the activity to find the sum of the angle measures of the angles in a triangle. Now, here we see that lines M and N are parallel. You can see that by the the pink triangles, right? That tells you that they are parallel. Lines P and R are transversals that intersect at point A. What is true about the measures of angle 1 and angle 2? And explain. So, angle 1 and angle 2 are alternate interior angles because they are on the inside of the parallel lines and they are on opposite sides of the transversal, right? And what do I know about alternate interior angles measured? They are congruent. Very good. What do we know? What is true about the measures of angle 3 and angle 4? So we know that that measures of angle 4 and angle 3 are also congruent because they are alternate interior angles. Number 3 says, what kind of angle is formed by angle 1, 5, and 3? So we want to know what kind of angle is formed by 1, 5, and 3. And we want to write an equation representing the relationship between those three angles. Now look at those angles. What kind of angle do they form? Because this is a straight line, when I add all three of those angles together, we're going to get 180 degrees. Okay? So, the equation that we could write is that if we add them all together, measure of angle 1 plus the measure of angle 5 plus the measure of angle 3, that's equal to 180 degrees. Finally, we want to use the information from problems 1, 2, and 3 to draw a conclusion about the sum of the measures of the angles of triangle ABC. And we want to explain our reasoning. So, the sum of the measures of angle ABC is 180 degrees. Okay? Now, the reasoning is because once let's see. Up here, we could say that the measure of angle 1 is equal to the measure of angle 2 because they are alternate interior angles. The measure of angle 3 is congruent to the measure of angle 4 because they are alternate interior angles. So, rather than writing the measure of angle 1 in this example 3, we're going to write the measure of angle 2. We'll write the measure of angle 2. Rather than writing the measure of angle 3, as we did up here in example 3, we're going to write the measure of angle 4 because they are the same. So we can say that the measure of angle 2 plus the measure of angle 5 plus the measure of angle 4 is equal to 180 degrees. So that tells us that when we add the angle measures of a triangle, what are we going to get? 180 degrees. Make sure you write that down. A triangle is formed by three line segments that intersect only at their endpoints. A point where the segments intersect is a vertex. Okay? So that's a vertex, and that's a vertex. Okay? The points where the lines intersect are called a vertex. The angle formed by the line segments that lies inside the triangle is called an interior angle. So, angle Z is an interior angle. Angle X is an interior angle, and angle Y is an interior angle. So, in this example, we have triangle XYZ. The measure of angle X is 72, the measure of angle Y is 74, and we want to find the measure of angle Z. Okay? When we add the measure of angle X plus the measure of angle Y plus the measure of angle Z, what are we going to get? 180 degrees. 180 degrees. Okay? So, now that we know what we're doing, we just put the numbers in, right? So the measure of angle X is 72, plus the measure of angle Y is 74, plus the measure of angle Z is what we're looking for, and that's equal to 180 degrees. So now we want to combine our like terms. Here are our like terms. So 72 plus 74 is 146. Plus the measure of angle Z is equal to 180 degrees. And now we just use our inverse operations to get the measure of angle Z by itself. So we'll subtract 146 here, subtract 146 there. So the measure of angle Z is equal to 34 degrees. The measures of angles the angles of triangle LMN are in the ratio 2 to 4 to 6. Now this is a little different than the example that we just went over, because the first one, the example was just X. So here, what are the measures of the angles? So let's say, let L, angle L, the measure of angle L, be equal to 2x. Okay? That's the measure of angle L. So now, if I add up all of the ratios, I'm going to get a ratio that equals 180 degrees, right? So this will be 2x plus 4x plus 6x, and that equals 180 degrees. So now, I'm going to combine my like terms and solve for x. So this is going to be 10x plus 2x is 12x is equal to 180. Then to get the x by itself, we will divide by 12, and help me out, what do we get? So x is equal to 15. Is that going to be one of my angle measures? No, because the measure of angle L is 2x, right? So that means that the measure of angle L is going to be 2 times 15, which is equal to 30 degrees. You with me? Now, to find the measure of angle M, we're going to use 4x. So this is going to be 4x. So we need to substitute the 15 in for the x. So 4 times 15 is equal to 60 degrees, right? finally, for the measure of angle N, angle N is represented by 6x. So this is going to be 6 times 15, which is equal to what? 90 degrees. Now, to check our work here, when we add the measures of a triangle, what am I supposed to get? 180. So, if I add the measure of angle L plus the measure of angle M plus the measure of angle N, I should get 180 degrees. Right? So let's see. 30 plus 60 plus 90 is equal to 180. Is that a true statement? 180 is equal to 180. Check. So we are correct. The exterior angles of a triangle. Okay, when we're looking at the exterior angles of a triangle, the measure of an exterior angle of a triangle is equal to the sum of the measures of its 2 remote interior angles. In addition to its 3 interior angles, a triangle can have an exterior angle formed by one side of the triangle and the extension of the adjacent side. So that's just extending the line, okay? Each exterior angle of the triangle has 2 remote interior angles that are not adjacent to the exterior angle. So here, like we said, the measure of angle 6 is going to be the sum of angles 1 and 3. Okay? The measure of angle 4 is going to be the sum of angle 2 and 3. And then finally, down here, angle 5 is going to be the sum of angle 1 and angle 2. You got it? All right. So let's go straight to our example. Okay? Looking at this picture here, we want to suppose that angle 5 is 147 degrees. Okay? We want to find angle 1. Now remember, that exterior angle, the measure of angle 5, is equal to the sum of the measure of angle 1 plus the measure of angle K. Okay? So, we've got 147 is equal to the measure of angle 1, which we don't know, plus the measure of angle K. What does that square mean?
90 degrees.
90 degrees. And now, can I solve for the measure of angle 1? Using our inverse operations, we will just subtract. So the measure of angle 1 is equal to 57 degrees.